Hello and welcome to Learn ADS in 5 minutes. This is tutorial 35 on parametric substrate simulation in ADS. What you will learn in next few minutes, a very useful concept of defaults design in ADS. And this is a new concept. We haven't talked about it during the previous tutorials under this playlist in the channel. We will learn how to define variable for substrate and stackup and then run parametric substrate based EM simulation in ADS. Before we start, subscribe to my channel, click on the bell icon to enable all the notification, and don't forget to hit the like button after you watch the video and click share to share it with your friends and colleagues who may be interested in watching. So let's go over each of these topics in a step-by-step manner to understand this concept, which could be very useful in certain cases. So till now we were talking about running an EM simulation. We learned about how to run momentum simulation, FEM simulation, and so on. And also we learned about how to define component parameters, both using nominal per tuple method as well as subnetwork method to parameterize our design and run a parametric EM simulation. But while we were doing all this, our stackup was static. That means the properties of stackup were not parameterized. However, in some cases, it's pretty important to even modify the stackup and parameterize it, just in case we want to see how much performance will change if a stackup properties varies plus minus 5% in terms of dielectric height or ER or loss tangent, etc. So this concept, what I'm going to demonstrate now in this video, will be very helpful. Now, the way we can define any variable in stackup by clicking on that respective item. And here, for example, if I want to assign a variable to thickness, I can type in h. And whenever we type h, for example, ADS senses this is not defined anywhere yet. So do you want to define it now? If you say yes, it will open a library definition window. And here I can add a variable and initialize it with certain value. So this way is simple. It creates a variable inside our design. And now this H is assigned to this dielectric, and which you can notice here, it uses some initial value. Now what happens behind the scene also, ADS creates a new cell here with a name defaults. And under this schematic, it basically prepares a variable what you just described. Now, as the name is suggesting, this defaults design is think it like a global variable. Anything which you declare here can be globally accessed in all the schematics layout or the stack up, definitions, and then you could parameterize the objects using the variables which we declare here. Now, by just naming it default doesn't make it default. Um, the way ADS does, or you can do yourself by creating your own schematic, if you go to options technology and under defaults design, you can see this defaults schematic is set up to be used as a default design. Now, in case you want to have your own design, because you can now also go from left to right, that means we can declare the default definition first, and then we can read those variables in the stackup. So let's see how we can do that. So here, if we create a new schematic and let's call it my vars, and under this schematic, let's declare a variable here and let's call the variable name to be ER and let's initialize it with a dielectric constant which we want to use in our stackup. Similarly, I can even declare a variable, let's say W, and give it a value, let's say 2. And this W I may want to use in my layout, transmission line. So I'll declare these two variables. But if this is like a regular schematic, this won't be read by the layout or by the stackup. So we need to make this as a default design for ourselves. So we can go to options technology, default design, and here we can select this option, add default design, and use my var as one of the defaults design. Now, whenever ADS finds you that you are using any variable and it can't find on the immediate design context such as layout or schematic, it will go and look up for the default designs. Now, if I go to my substrate again, and here let's go to material definition property, and the dielectric one, this is the material used in this stack up. which has a fixed number 3.66 assigned. So I'm going to use my ER, and this variable we just declared ourselves. And here when we click OK, ADS reads the value of ER from the default design. So you either declare the variable in the schematic, stack up first, ADS will automatically update your default design, or you define a variable there and use it here. So both ways it is possible. Now, once you have this stack up, I can go back to my layout. And this layout, we do a regular EM setup like we have learned in the previous video tutorials. So here I'm generating an EM model, and I could go ahead and generate a symbol, which is like a layout lookalike symbol. And if I go back before just I run simulation, notice there is no EM model assigned here. So once we hit simulate, now ADS will generate a EM model, perform the simulation, and show you the momentum simulation or FEM, whatever you prefer to work. So this looks like a desired response of a low pass filter. Now if you look under EM model here under database, we can see the data got generated with this H and ER value. So now using the regular COSIM approach, I already have a placeholder here. I can place this layout component. And now here on this design, I'm already defining a parameter sweep to sweep H. And this H is getting swept from 20 to 50 in a step of 10. That means basically we are going to run 4 EM simulations in the background with different value of dielectric height. And every time we run this as parameter simulation here. So there's nothing new. This is like a traditional EM COSIM. And after all the simulations are finished, we can look at the job manager window. ADS ran, 4 EM simulation sequence. We have the plot of S21, S11, which you already set up. And here each color of the trace is representing results over various dielectric height value. And also the EM model, which we originally only had one value inside. Now, if you look at database, it has value for different height. Similarly, if we sweep ER, we will have values for ER as well. So using this technique, not only you could parameterize the layout, you could also parameterize the stackup, and under single simulation, you can run sweeps on both stackup properties as well as your layout properties. Now, one last thing before we close out this video. Now let's clear this mesh. Remember we declared a value W, and instead of going into parameters from components and declaring a subnetwork and declaring a value W here and then using in the line, because we already have a W defined under default design, I can double click on this component under this parameter here. I can type in W, and remember there we didn't declare any unit, so we can use unit from here. So WMM, and once we click OK, ADS layout becomes a 3 mm or 2 mm in width, what we just declared here. So using the same concept, now even your layout can be made parametric, and all the variables you want to control, you can keep defining it under global variable page, which is what we call as default design, and run all kind of parametric simulations. So that's all for this video. Hope you like the content presented, and it will be useful for your design work, doing a lot of interesting analysis using ADS simulator. Again, don't forget to subscribe to my channel, and thanks for your time. Happy designing.